So picking up with the second video here for this pre-lab for Lab 3, we determined that the angle 153.4 and let's see, what else did we want to find? Omega 3. So if we go back to here, omega 3 2.5 as we expect. And of course the negative 2.5 means that it's actually rotating clockwise. Okay, so we'll take a look at for the lecture notes here. You do have that instantaneous centers demo, the SolidWorks part that you can play with, and then there's also from a previous quiz a problem here that you might try without looking at the solution. Then you can check out the solution. There's also another velocity crank example. So it's this one right here. So you can see this has some different numbers, and I've also added in, where the instantaneous center turns out on that one. And there's also a MathCAD file for this problem right here. And it's just, again, setting up the same equations and then just using MathCAD to get the results. So you can take a look at that if you want to. And again, these are all found, including the MathCAD solution, they're all found on Canvas under this Lecture 10. With regard to Lab 3 now, if we look at some of the work that you have to do for this lab, you have to use either AlgoDo or the Norton linkage software to generate position velocity curves as well as the velocity of the coupler for this mechanism right here. So you can use inches for this if you want in terms of when you do the simulation. We're mainly interested in the shapes and the path. And so this is just a screenshot from AlgoDo where so here's the coupler right here. Obviously that's the slider. Here's the crank. And then this link right here is just fixed at 60 degrees. So there's the coupler point of interest. It's going to be 60 degrees and a distance of 12 units, whatever you decide to use, from this pivot where it connects to the crank. So if you want to use, let's see, let's go to the lab. Okay, so you can see again here some dimensions on this thing, and there's some AlgoDo files that are already set up here that you can take a look at. Obviously, for your own, you'll want to start from scratch on your own. I take that back. You can use this starter file to start with and then put in the link connections and whatnot. And this is another file that you can look at. So if I bring those up, all right, so this is that first AlgoDo file, which you can download this and actually start with it and then set up the links. And if you do set up the links, then you'll want to end up with something that looks like this. And if I run that, you can see you generate some of the different speed versus time of the coupler point, the angular velocity of the coupler as a whole, and the position, the XY position of that point on the coupler. So that's one way that you can do it. The other way you can do it is with the Norton linkage software. Here's the setup in using the Norton software. So the length of link 2 is 6. The length of link 3 is 15. The offset from from O2 perpendicular to the slide axis is 3. And the slide axis in this case is at 90 degrees. And then the distance from the coupler is 12 inches. And the angle from the coupler from the link itself is 60 degrees. So if we do the recalculate on this, you can see what we're talking about here. So here's the slider axis. The offset is 3, as you can see right here, but the slider angle, and actually I'm going to have to stop here and pick up with the next video.